Hey guys, good morning. Today we're going to do a lesson on the solar system and units of measurements. I'm going to pull up the screen and then Ms. Bremer's going to take over and then we will get started. Hopefully I do this better than I did the other day. Okay. Well, I just clicked on you and I don't know what it's doing. Oh, no. Oh, wait, I think it's going to work. Okay. It said it's too early this morning.
It is early. I've been up since 5, guys.
Well, I know I have it. Where'd it go? I wonder if I can just pull this one. Yeah. Here we go. All right, can you see that, Miss Bremer?
Nope.
Ah. Okay. Why is it not? Okay. It's not showing me the slideshow when I go to share it.
Okay. Let's see.
All I see is mine, and I know that you shared it with me. Wonder if I...
Do you want me to share it? Well, you need to.
Okay, hold on. Let me
You need to. You have to annotate the.
Because I think all I had to do was click add to my drive. Sorry, guys. Still learning here. Hold on. I think. Oh, found it. All I had to do was click add to my drive. Oops. Here we go. Now I think it's working.
Here we are.
All right, now let me click present. Maybe. Here we go. Okay. Do you need this slide, Miss Bremer? You just give me a thumbs up or 10 to the next one.
Okay, yeah, like Miss Burke said, we're going to be doing solar system and measurement. So you can go to the next one. Now, you guys are familiar with the solar system and the planets, but have you ever heard of terrestrial planets, Jovian planets, Oort clouds? Is that a new one for you? And the asteroid belt. We're going to watch this video, and at the end, you'll be able to tell me all about these.
Okay. Oh. What?
Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4
The sound lagged out. Miss Sparks, can you hear me? The video sound went away.
I didn't realize that would mute the video too. Do I need to rewind it? Oops. Okay, let's start over. Sorry, guys.
Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own sun. Revolving around the sun are 8 planets. The planets are divided into 2 categories based on their composition, terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system since that is where the gravitational and physical influences of the sun end. Our solar system's particular configuration of planets and other celestial objects, all revolving around a life-giving star, make it a special place to call home.
Okay guys, now that you've watched the video, we can move on to the next slide. Now, here are your 4 questions. If you need to rewind or video to go back and find the answers, that's fine. That's what it's there for. Question 1 is what are the 4 terrestrial planets? The video explained that to you. Okay, you need to answer that and write it down. What are the 4 Jovian planets? What is the asteroid belt made of? Okay, so you need to put on your paper what it's made of. And where is the Oort cloud and what is it made of? Guys, what I want you to do is, if you don't know the answers, if you don't remember, rewind the video, go back, find the answers, write them down, and you need to bring them to our Zoom meeting tomorrow, okay? Miss Sparks is going to go over some math with you guys.
I think another cool idea too, Ms. Framer, would be if they wanted to do some art activity, is to actually draw out all of those planets and the astro belt and stuff like that, and they could show it to us tomorrow too. That would be cool.
It would be cool. Yeah.
I thought about that when you were going over the questions. Okay. All right. Let's go to the next slide. So what I'm going to do is I'm going to leave it on this slide as I briefly read through some of it. I'm not going to read through all of it because I know that it's like 3 different paragraphs and there's 2 more slides with paragraphs too. But I'm going to leave it on this slide for a couple minutes just so that way if you need to go back to look through for your answers to your questions, you'll have it there to read through, okay? All right, so this is a brief history of units of measurement. So it says in order to measure a distance between 2 objects, you need 2 things. You need a unit of measurement and a tool that you're going to measure with. In early times, people used their body parts, such as their thumb or their foot, which was kind of hard because, as you know, not everybody's thumbs are all the same size, and we all have different size feet, which is cool because we don't all wear the same size shoe. But in the old days, where it says about 950 years ago, that's what they had to use because they didn't know anything. I thought it was kind of cool right here where it says a yard was the length from the tip of the king's nose to the end of his fingertips. So that's kind of weird to use for a measurement. There were different types of measurements. It says something about if I were to measure my bedroom with my feet, it would be different as if Haley were to measure my bedroom with her feet because she has way smaller feet than I do. So it wouldn't be the same exact measurement. Okay. Now, eventually, they agreed on different standards to help them with their measurement. The Romans like to divide things in units of 12, like 12 months in the year, because, you know, we go from January to December, and that's 12. They finally decided that a foot was going to be 12 inches long. Once the standards were set, everyone agreed on the lengths of units of measurement. The system worked better, but it was still not perfect. Because as you know, even when we try to start doing something, we've got to work out the kinks. Like with our Zoom meetings, we have to work out the kinks. Eventually, we will do one super awesome. It says in the 1800s, the French Academy of Sciences was asked to develop a system of measurement that was based on scientific measurements and used the base 10 system. That one talks about kilometers. It says kilo means 1,000 and centa means 100. Now you'll have to remember that for when you start doing conversions. Larger and smaller units were made by multiplying or dividing a meter by factors of 10, which I think some of you might have touched on a little bit in 4th grade, not as much. We hadn't touched on it yet this year. By the year 1900, 35 countries decided that the metric system would be their standard unit of measurement. We, however, in the United States did not decide that the metric system would be our standard system of measurement. Okay, this is the last slide with the paragraphs. So they talked about, and I thought this was interesting, they talked about kilometers being useful for measuring distances on Earth. However, kilometers are too small to measure things like out in space, like Ms. Bramer talked about the different planets and stuff. So they had to come up with a different unit of measurement, which they talk about, and it's called an astronomical unit. So the average distance between the center of the Earth and the center of the Sun is 1 astronomical unit. And it talks about this distance is 150 million kilometers, which is roughly the number of kilometers between the center of the Earth and the center of the Sun. That is a lot. Oh, hold on, I didn't mean to do that. Okay, when leaving the solar system and looking at other star systems, the AU is too small. So they created a larger unit of measurement, which they call a light year. And it says, okay, it says that scientists measure a light year as the distance light can travel in 1 year, which seems like a lot. Our system of measurement has evolved from using thumbs to feet to using light in 1 year. So, and here's a good diagram to show the 1 astronomical unit, because this is the center of the Earth, and this is the center of the Sun, and that's an astronomical unit. Look how many kilometers that is. That's crazy. Okay, so here are your questions. Now these questions or these answers you'll find from the 3 PowerPoint slides I just went through. And if you'll just write your answers down, and then we'll talk about them tomorrow. Number 1, what is the problem with using parts of the body as a unit of measurement? Remember, I mentioned Haley as that for I measure my bedroom with my feet and her feet. Number 2, why were customary or standard units established? Number 3, what is the advantage of metric units? So like, what is the benefit? Why is it good? Number 4, why is using kilometers to measure distances in our solar system a problem? Remember. Number 5, what standard unit in astronomy was developed to measure large distances? Okay, so there's those questions, and I'll leave it on that slide for just a second. That way you can write down your answers. And then the next slide is when we'll actually get into the math. This one, it says, looking at the picture of the ruler marked with inches and centimeters. If you look, the inches are at the top with the 1, 2, 3, 4. Centimeters are at the bottom. It goes all the way to 10. We see that there are approximately 2.54 centimeters in 1 inch. So you're going to write that down. So 1 inch equals, and let me pull out my whiteboard so I can write that down and show you. Now remember, this ain't going to be pretty, so bear with me. 2, and remember that decimal point says and this would be 54 hundredths centimeters. And then it says, now that you know there are approximately 2 and 5400 centimeters in 1 inch, use this information to solve the problems below. There are many ways to find the answers. For example, you may use a ruler like they did up here, or draw a picture, or add, multiply, or divide. Now, I'm going to give you some hints. For number 2, it says 5 inches equals how many centimeters? So remember, you're going to use the 2.54. I am going to give you a hint that you should multiply, okay? Now the next one, 10 inches equals how many centimeters? This one, we'll go here. Now this one, if you look at it, 10 is 5 times 2, right? So we can add this answer. We can add it to itself twice. Does that make sense? Maybe? If not, you can just take the 10 and multiply it by 2.54. Okay, and if you have any questions, you can message me or Miss Bramer, and we don't mind helping whatsoever. Okay, does that make sense? All right, so let me clear that out so we can go to the next slide. Clear all drawings. Maybe it'll go away. Okay. All right, and the last slide. Ms. Bramer, do you want to take back over?
Sure, I can. Okay. Now, guys, we're going to meet tomorrow morning, which will be Tuesday, March 31st. I had to look at the calendar. It's easy to lose track of days right now. At 9 o'clock tomorrow morning on Zoom. We'll both send you out links. So you need to do this today, have your answers written down, and come in and be prepared when you come into the meeting tomorrow at 9 a.m. Okay? All right, guys, have fun. Have a good day.
All right. We'll see you guys tomorrow.